Hello, Mark Wolf here, and this is a project I did for an AI assignment. It's top-down 2D destruction derby, as you can probably tell. The part of AI that I was looking at was steering behaviors. This includes 4 steering behaviors: seek, flee, wander, and a wall avoidance behavior. It includes the Physika physics library, which is a processing wrapper of JBox2D, which is a Java implementation of Box2D, which is a very popular 2D physics library. Um, it was quite hard to implement because initially I had all my AI elements set up before I was bringing in my physics. So the way I had to handle it was I basically had to have my physics world update based on the readings I was getting from the AI, and then I'd have to update the positions based on the physics world. So that was a bit tricky. I had a bit of problems with that initially. All the artwork you've seen is done by hand. You can probably tell it's not AAA by any means, but I like to do kind of stuff by hand. I don't like taking copyright stuff because in the end this is going on YouTube, and if I have copyright stuff, then it's going to get taken down. So what's the point? I like doing my artwork myself. The tires, the skid coming from the tires is just done within the array list of positions, and then just drawing lines based on previous positions. The damage is done, if you can probably see the little black specks on the cars, that's done by using the set method in processing, which is an image function, which it takes a pixel and sets it to a color, and what I'm doing is taking a random pixel on the car and setting it to black if it's been involved in a collision. So the more collisions, the more black dots, the more damage the car is. And when a car dies, like in this case, there's only one car left, and they have a red circle around them. There is also debug mode, so let me just reset the code. D goes into the debug mode, which shows all the different steering behaviors. The circle is the wander, and then the other 3 colors are for velocity, desired velocity, and the forces like that, where they're going. Red cars, the dead cars in this are red, just turn red. When a collision happens, the cars are set to white, otherwise the cars are just black. So that's debug mode, quite nice to see what's going on behind the scenes. So how the steering works, basically each car has an enemy car. That's basically their car objects. Each of these cars are their own little individual class, and their own individual object. So every car object gets assigned an enemy car, which is literally just a random loop through all the other cars that are alive. As long as you're not yourself, so as long as you're not targeting yourself, you can face that enemy car. And the way it works is sometimes if you hit a car, if you collide with a car, there's the chance that you randomly switch your enemy, which leads to more exciting behavior of cars not always going after the same car, but going after different ones. So you'll always be seeking a car. You'll always be trying to go towards the position of a car, as long as your health is fairly decent. I think it's if their health gets below 5, that's when they have to start. That's when they start fleeing. But if their health is below 5, as long as they have a health greater than their enemy, then they can still seek that car. And what that does is it stops all the cars at the end just fleeing from each other, and then the round never ending, essentially. There's wander code involved in it, as you saw from the debug mode. The wander code isn't implemented in full. It's just it's a weighting. It's a small weighting because it doesn't really make sense to have cars wandering around in a destruction derby. That doesn't really happen in destruction derbies. You're always trying to hit someone. So it's not been implemented as you might see it implemented in other code, but it is there. And then there's a wall avoidance code, which means if you're getting too near a wall, you pretty much flee from that wall, which has the same effect of pretty much just turning away and steering away from that wall, which makes sense. It's pretty simple, but it makes sense. So some of the game aspects of this is when 2 cars collide, one of the cool things that Physika allows you to do is to get the velocity at that collision. So they lose health based on a scale of that velocity. But they don't lose health if a car collides with a wall or a dead car. I did it when it doesn't collide with a wall because of the velocities I'm working with. You can often see the cars hit into walls, not by choice, but they're just going too fast and they can't steer out of the way in time. And also I don't have them losing health if they hit a dead car because I haven't got object avoidance in at the moment. So if one car is trying to hit another car that's on the other side of a dead car, they'll just hit straight into the dead car until they can get around it and hit the other car. So I didn't put object avoidance code in, mainly due to a time constraint, and that's why I don't penalize the AI for hitting into dead cars, pretty much. So some of the improvements I could have is sound. Sound would be pretty easy to put into it. I'm already detecting when collisions happened, so playing a sound over the top when that happens of a crash is probably not too hard. Obstacle avoidance, as I said, would be useful for avoiding dead cars. And putting in a player car, so a player can actually play the game and try and smash other cars up, is it's probably easy enough to put the ability to have a car be controlled by the player. That's probably not too hard. But the actual sort of tweaking the AI to make it challenging is probably where it's going to be hard. It's probably pretty easy for a player to come in and win this all the time. So you'd probably have to tweak the AI to maybe chase after maybe have a higher weighting towards seeking the player rather than seeking other AI cars. So that's where the difficulties with that would probably come in. One other thing, when a car is dead, essentially when it loses all its health, it stops having any forces applied to it, and I also give it a greater density. I don't set it as a static object, which is one of the things I started off by doing, because then they literally can't move anywhere. And so you can sometimes get live cars being trapped in dead cars because they can't move anywhere. So I just give them a high density, so if a live car hits a dead car, it can still move, the dead car can still move, it acts more like dead weight. It's a lot heavier, it doesn't move as much. And one of the cool things in Physika is you can just sort of like drag the bodies around. So I can actually show you, so this is a live car, hit into a dead car, it doesn't move as much as the live car moves, but it does move a little bit, allowing you to get round. So that's my AI implementation, also putting some physics there for fun. Hope you enjoyed it. See ya.